Good morning to you. I'm not going to go through each and every slide verbatim. I'm going to open a discussion about water resource management generally and some of the challenges that we're facing right at the front line. Now, over the last sort of 20 years, we've realized that water has been mismanaged. Water's been mismanaged at every level, from within cities to even our communities. We're leaving old water resources redundant, neglected, and in fact in many areas we're actually infilling ponds, lakes, and so on and so forth. What we're realizing now is that we don't have many choices left of where we get clean water from. So one of my roles over the last sort of 15 years is to identify potential new technologies that are going to assist us in disaster risk reduction. Interestingly, earlier this week there was a global conference on water in Paris. I don't think any of us knew. And yet water, I think, should be quite strongly and firmly within disaster risk reduction. I don't think there's an agency here that doesn't have one form or another a challenge with their water. Accessing water, keeping water clean, moving water around, storage of water, health within water. So I've now been working with and encouraging a group of scientists from Finland. So to give you a bit of background, these are the ex-Nokia telephone senior management scientists, research and development, retired, got bored, said we can do something better with what's been going on at this present time. Now, so if I'm going to work my way through a little bit more. Let's see if we can get this thing to work. All right, how's this one? There we go. Okay, so just look at the background here. Water resource management is not just about treatment. It's not just about distribution. It's not just about being bottled and being distributed. It's about the creation of water, conversion of water, natural sources, and then there's obviously the discovery, which is going on all of the time, or trying to. And in Kenya, only a few years ago, we discovered one of the largest aquifer lakes ever discovered. And that, in fact, was discovered by satellite. Catchment. We have floods all over the world, and we watch it all go out to sea. What an enormous waste. And we say, well, that's polluted water. But then if you go and look at our rivers, they're equally polluted anyway from industry. So catchment is a vital sector which we need to properly address. And it's one of the areas I'll be addressing when I go up to Nepal during this summer for the next X number of months, to look at the small communities where they can create catchment, storage, and better use of their water resources from their rains and so forth. Recovery of water, well, we've got challenges all over the world where our water and reservoirs, our lakes especially, and canals are in a horrendous state. I'll be working with the Bangkok municipality on recovering the canal system there, the water quality. They're dealing with the infrastructure, but the water quality on how you actually address this without very, very expensive water industry treatment works. We can't afford that. We can't afford the footprint. And within RO, reverse osmosis, 50% of that water gets discharged back as highly polluted, back into the sea, or indeed back into our deeper aquifers. And that's a disaster. It's an ecosystem disaster. So why do I mention that? I'm now looking at what other options do we have. Now the Nokia boys said, okay, atmospheric water, it already exists. And indeed, there are lots of industries trying to take advantage of developing atmospheric water, the access to atmospheric water. Now, whether you realize or not, there's the equivalent of every runoff of every river around the world. 4 months of that is sitting in our atmosphere. Now, we even heard from meteorologists earlier this week that because of global warming, we're going to be evaporating even more moisture into the atmosphere. So, why don't we access it? Well, some areas of industry try to do this by cloud seeding, weather manipulation. Okay, that's fine, but it's very sporadic. It can produce an enormous amount of water in a gush, and in fact, you end up flooding areas, and again, it's back down to not having efficient catchment. But that's still progressing, and I worked with some scientists on weather modification in the last 8 years as well, and that's not the subject today. So, what are we actually wanting to, and I'm not relating to these slides because this is being videoed, okay? So when someone's reading the slides, they're going to want to take some time on reading it. So the atmospheric side of water is an enormous resource to us. And if you, I don't know if you ever realized that when water evaporates, it purifies itself. Water from the sea purifies into drinking water. Water from a dirty lake evaporating purifies itself. It's one of Mother Earth's little mechanisms that we simply don't take advantage of. So the challenge is, how do we actually make this into a commercial business model? And I say a business model not to be making money, but to be efficient. All right? If you don't have efficiency, then it becomes lax and you don't have any sustainability. So what the industry have been doing to date is setting up atmospheric generators, atmospheric water extraction generators, but they predominantly make their money out of selling you their filtrations, their chemicals, and they don't sell the water. They sell you everything else apart from the water. And that really, from our point of view, is a wrong approach, especially in this day and age where we're looking for sustainability within the communities. So we addressed this very differently. We said, right, we can minimize the amount of filtrations because we're not dealing with the same heavy particles as in running water, and we're only addressing the very fine particles within the air intakes. Now, obviously, we cover the output of the water with ultraviolet to make sure it is neutralized from pathogens' point of view. Now, the interesting thing is, did that slide go for what I think it did? The interesting thing is that we've realized now we can really minimize the whole infrastructure of this, and we can concentrate then on making it a smart system. And it needs to be a smart system in order to make it easy and controllable on a remote basis. So, now I'm going to sort of just run through the actual technology themselves. This is the team from Finland. I've covered most of this statement already, and I'll just leave it there for the video's point of view. Now, what we're actually looking at is smart technology that within the process, we're able to maximize the use of the humidity and temperature. Now, under normal circumstances, you've got to have a pretty good balance. But what we've achieved is that through smart technology and through the smart software from Italy, we're able to use much colder air and much less humidity and still have a continuity of water production. Right. So we don't necessarily need high humidity and warm air, because it's the warm air that comes in over the system which condenses. All right? And I'll show you a little diagram about that in a moment. So the whole aspect of this is to sell the water and to provide it for remote communities, and this is most important. However, we've had an enormous uptake from cities like Brasilia, we've had Philippines, South Africa, Ghana, And in fact, the Finland government have agreed to initiate some of the seed funding for all of those countries. We've got 6 countries initially, but we've had many more approach. Simply because we can scale this up. We don't actually have to produce the water in the middle of the city. So we don't actually have to put ourselves in the middle of air polluted environments. We can sit this outside. We don't need infrastructure, so we don't need water being piped to us. We can actually it can be put straight into containers and distributed accordingly, or back into the distribution system which is already existing. This is what the system looks like at a mobile system. This is not the scaled up system, this is the mobile system. And this is producing about 1.5 cubic meters of water per day. So between 1,000 and 1,500 litres per day. And this is a small system, 16-foot trailer, and can be mobile, driven out. It can be a response to emergencies, whether the water is being cut off. We can use it for aiding in drought environments on a temporary basis. And oil rigs, ships at sea, all of these are able to use the same system. Now, obviously, the clever part of this is that stresses the software. This is what makes it very, very different to the other areas of the industry. So we can remotely control this. We can remotely turn the tap on and off from the storage, and that doesn't matter where we're talking. We've heard earlier this week about satellite technology having easy access, and now it's all affordable. So there's a trailer that goes behind any particular truck, vehicle, can be towed into site. This is not our actual system. This is the standard system. Now we've been able to extract a lot of that components out of there. All right. So, but this gives you an understanding on how it actually works, and it is working. Offices around Dubai, I've seen these small units there, just trickling water into their receptacles. So, and then in South Africa, some very large facilities, and they're producing, several thousand litres a day, but again, on a different business model. And some of the statistics here on how we address and what we're actually capable of doing within certain parameters. So beyond that, when we put a submission in here, we're asked a variety of questions. Is the technology innovative? Yes, the technology is innovative, because it's changing the whole business model. We're reducing the consumables within this. We can scale this up to, we think, hundreds of thousands of litres per day in a footprint which is affordable. We don't need excessive heavy infrastructure. So the challenge of this is, and within the communities like Brasilia, they're looking at putting 6 or 7 different plants around the whole outskirts of a city in order to sustain their water during shortage and top up. Absolutely vital we consider this for even our own buildings, our own homes in the future. In Dubai, we have a city, a small development called Sustainable City, where they recycle every little bit of their water. So this type of system they're not using yet, and yet they're showing interest now. Okay? So to really sort of wrap up on this, and I'll just finish off these last couple of slides for the video's point of view. It's new, it's coming to the marketplace, it's being offered and will be offered to governments as well as remote communities, remote organizations, and just please watch this space for the future, because in the future we're going to have to change our whole approach to understanding water, and Mother Earth gave us this process of evaporated water, and yet we do not use it to any capacity whatsoever to date. But that is going to change. Thank you very much. And any questions, or indeed if you want a download of this, I've got it on a stick and we can download onto your computers or whatever. I shall be putting it up onto our website as well. Thank you.
Thank you so much, Garry. And is there any quick question from the audience? Okay, just one question. Yeah? Okay.
Yes, sir. What is the selling price per cubic meter of this technology?
Okay, so we've had to make sure that this is very competitive. So we're able to move a liter of water out at approximately 0.001 cents a litre. Now, bearing in mind, water to oil rigs is about $5 a litre. That's what it costs them to get that water on board an oil rig, or to generate their own water.
Thank you so much.